everyone, and thank you for joining the inaugural APN Digital Summit. We have put this APN Digital Summit together to help our APN partner community to learn some of the AWS services that we feel our partners can make a strong impact to AWS customers. The services you will learn about today will enable you to transform your business and innovate on behalf of customers to better meet the business needs at a significantly lower cost. Feel free to attend as many sessions as you want. We have 20 sessions running over the course of 4 hours. Once you register for a session, listen in as we dive into the content. We will be sending out an email communication for each track with in-depth resources and trainings for you to continue your education within these service areas. We will also be sending you a survey link after the presentation. This gives you the opportunity to provide feedback so we can grow this series for our partner community. We also provide the opportunity for you to tell us what content and services you would like to learn more about so we can help shape the direction of this APN Digital Summit and what we host in the future. A few housekeeping items before we get started. First, the session is being recorded. We will send you the recording when this presentation is over, along with the additional information I just mentioned to help you continue to learn more about these services. If you have questions during the presentation, please feel free to ask them in the question window. We will do our best to answer all the questions as they come in, but if we don't, we will follow up in an email after. If you are having any audio issues, please try your computer's mic and speakers. This often fixes any problems that you may have. Thank you again for your time today. I hope you enjoy the sessions we have for you, and we look forward to hearing what you think. Now, I'm going to hand it over to our presenter.
Hello, everyone. Welcome to APN Digital Summit. My name is Binoy Das. I am a partner solution architect in AWS. And today I'll be talking to you about serverless compute. I'll give you a quick introduction of serverless compute. We will start with a background of how computing has evolved over past few decades. Then we will move on to defining serverless compute as we define the term in AWS. From there, we will move on to discuss some common serverless use cases. And then we will finish up the presentation by discussing some of the key customer examples and how they succeeded by using serverless computing paradigm. So that being said, let's get started. To begin with, let's take a look at how the computing has evolved. Back in the time, physical data centers and the physical servers in the physical data centers were the only way if you wanted to deploy your application and distribute it to your users. Going forward, we made this process more efficient by using virtualization. With virtualization, many of the same basic hardware-driven limitations still exist, but it still gives you some advantage in having better resource utilization of your servers. And moving on, finally, we brought these virtual servers into the cloud. And this move helped us free from the physical limitations. But we still had a lot of work to do to build and scale large software projects. So each progressive step was better and provided more value than the previous. For example, with the virtualization, it gave us the benefits of higher utilization. It also increased the provisioning speed because now when your team needs to provision a new server, instead of obtaining a new rack of the server in your data center, you can simply provision a new virtualized layer on the existing rack space that you already have. Because of this fact, it also improved the uptime of the software. It improved the disaster recovery. because when some of your virtualized instances die, you can easily recover it onto another virtualized instance in the same data center or even sometimes in the same rack. It also provided hardware independence, meaning that now you can take your virtualized host operating systems and run it on any available physical rack server that you have. In the next stage, moving on to the cloud, all of these benefits carried on. In addition, now companies were able to trade their capital expenditure for operational expenditure. It also allowed them to achieve more scale easily. The resources were elastic, so now the resources could be provisioned on demand, and that in turn contributed to faster speed and agility of software development teams. It also helped reduce the maintenance overhead of the servers because in this model, the cloud provider takes care of all the maintenance and patching activities of the underlying hardware and the host operating system. And due to these facts, it provided even better availability and fault tolerance for your software. But there are still limitations if you think about it. Even with virtual servers in the cloud, you still need to administer your virtual servers. You still need to manage the capacity and utilization. It is understood that cloud is elastic, but elasticity needs to be planned ahead of time. You still need to size your workloads. You still need to configure your auto-scaling groups. You still need to manage for availability and fault tolerance. And on top of all, it is very expensive to run intermittent jobs because with the virtual servers, even they are on the cloud, if you do not turn them off when they are not in use, it may lead to cost overrun. So where do we move on from here? In our next stage of our journey, we move to serverless, which we call the freedom from the Iron Age. So how can we meet the future needs? By further reducing some of the friction in the IT management process that keeps us from rapidly introducing and scaling new applications. The answer is serverless computing. The future of the world is enabled by serverless because it has all the compute power you need, but without the operational burden and complexities of dealing with servers. So what does serverless mean? Some of the key attributes of serverless. Number one, there are no servers for you to provision or manage. The cloud provider, AWS, does that on your behalf. Second, it scales with users. So you do not have to do any capacity planning or even any scalability planning for your applications or the servers behind it, for the simple reason that there are no servers that you are deploying your application onto. Another great benefit in terms of cost is that you are not paying for idle. Imagine your application is running very intermittent requests. In some hour, you might have only 100 requests coming through. In the next hour, you might have 1,000 or 10,000 requests coming through. In a traditional model, you have the server running with the same load all along, and you keep paying for every second that your server is on. With serverless, your execution environment is brought back to life only when there's a request that you need to process and respond back to your users. And lastly, availability and fault tolerance are all built into the serverless service. Just like any other managed services that we provide in AWS, we deploy our services into multiple availability zones within the region, and you have the option to provide further fault tolerance and availability by choosing to deploy across different geographic regions on AWS. Now, you might be thinking, why now? What is the history of serverless? So going back to the beginning of AWS, you see that one of the first services that we launched back in March of 2006 was S3, which is the simple storage service. This service was the first move towards the serverless paradigm. Prior to S3, the only way for you to store data is on your file system on your computer. Next, few months later, we launched Simple Queue Service, where we took the same approach but extended it towards application integration. With Simple Queue Service, remote application can be loosely decoupled and still send messages to each other without the need of having to maintain a server to manage the communication between the applications. Fast forward about a decade, came Lambda, which is the extension of the same computing paradigm, but this time for the core of the computing, which is the compute platform. So AWS Lambda is our serverless platform, which is globally available in all of our public regions. Like many of our other services, the Lambda service is compliant with many third-party audit programs, such as SOC, PCI, HIPAA, ISO, and FedRAMP. So using serverless, many of our sensitive customers in the field of government, healthcare, banking, and insurance can run workload in a manner that is compliant with the regulatory authorities. Additional benefit of serverless is it is natively integrated with 17 other AWS services. And that makes easy for you as a customer to innovate upon the application integration patterns and architectures. Before going forward, let's take another quick recap of what benefit does that give when it comes to the consideration for your application development. In a traditional model, when you deploy your application, that is often the last step. The effort starts from procuring a physical infrastructure and often maintaining a virtualization layer on top of your physical infrastructure, and then maintaining a guest operating system where your code is going to run, and the language runtime where you are running your code, and finally, your application code. It's a tall order. So if you look on the right side of the screen, you will see a long list of responsibility that you had to manage just to be able to distribute and deploy and distribute your software. With virtualized server, some of these responsibilities are taken off of your IT team's responsibility list, such as power, cooling, facilities, your physical security, and virtualization platform. With the serverless, though, the rest of the responsibilities, such as maintaining a host and guest operating system, access logging, maintaining the upgrades, deployment of the application, health checking of the hosts, and fault tolerance and node replacement, all of these are now handled by the cloud provider, in this case AWS, by the Lambda service that we have behind the scene. And your responsibility now is only to deploy the application code. And then to add to that, we also have services like CloudFormation that allows you to procure infrastructure, or Lambda serverless compute platform in this case, using code. So you can bundle your infrastructure code seamlessly with your application code and achieve a one-click deployment and distribute and deploy your software. So when it comes to the serverless application, there are a few common building blocks. Obviously, it all centers around the AWS Lambda, which is the linchpin of serverless computing. Think of Lambda as these microservers that is managed by AWS and that springs into life only when your code is executed in response to some event happening. So serverless paradigm is based on event-driven model. Now, where does the events come from? The events can come from many sources. One major source of events come from Amazon S3. So Amazon S3 is our general purpose storage system where any structured or unstructured data can be stored upon. AWS Lambda is natively integrated with Amazon S3 so that you can program Lambda code to execute whenever a new file is uploaded to your S3 bucket or any of your existing files are modified in your S3 bucket. And that provides a very convenient way to have your application communicate with each other just by storing the file into Amazon S3 buckets. And not only does it allow for seamless integration, it also helps the application maintain a very decoupled nature. On the database side, we also have Amazon DynamoDB, which is our managed non-relational database. And when it comes to serverless architecture, Amazon DynamoDB provides a strong boost in performance as opposed to traditional database model. Because with DynamoDB, you do not have to manage any servers to maintain your database as well. Then comes the messaging queues, which is the Amazon SQS that I was talking about earlier, and Amazon SNS, which is the simple network service. So with SQS and SNS, it provides further ways for your application to communicate message to other applications or your downstream clients to send message to your backend services. Another key component of serverless is step functions. So think of step functions as step machines. If you think about it, AWS Lambda can execute your code one piece at a time. But in enterprise applications, there are many cases where you have to run a long-running process which is composed of several steps, and many of those steps need to be synchronized and run conditionally upon the state of the previous task. So under such circumstances, you can use AWS step function to chain multiple Lambda functions together and achieve a long-running process in a completely serverless fashion. When it comes to analytics, that is also a key component that people are using with the serverless computing. And Amazon Kinesis is our data ingestion service that helps you to ingest high-speed data from sources like your website clickstream or maybe your IoT device sensors on the field. So Kinesis helps you ingest high-speed data into your application either directly onto Lambda or onto S3. And then in turn, you can use these to trigger AWS Lambda to conduct processing which can replace your traditional ETL workload. Another application architecture that customers are using today, which is very commonly known as microservices architecture. In order to achieve microservices architecture, Amazon API Gateway is another component that customers typically use along with Lambda. With API Gateway, you can expose your application services as API Gateway endpoints to your external third-party consumers or clients or downstream system users. And finally, with AWS X-Ray, it makes the monitoring and debugging of your Lambda runtime extremely easy. So you can even automate the monitoring and debugging, inspect the logs, and take actions accordingly. Let's take a look at some of the common use cases. Number one use case is web application. So web applications can be hosted in serverless fashion using S3. To begin with, in order to host the static websites, you can use S3 to host all the HTML, JavaScript, and CSS resource that represents your website. But you don't have to stop there. You can go one step further from that and even host your complex web application with the interaction with backend using the same application architecture. With the serverless model, you can use Lambda function, which talks to your serverless database, which in this case could be DynamoDB, and then you expose the functionality via API gateway. On the front-end side, the JavaScript running from your browser can directly communicate to the API gateway endpoints and send data and receive responses, and you can display the responses accordingly to your website. So you see, using these services, S3, API Gateway, AWS Lambda, and Amazon DynamoDB, you can make very complex web application in a completely serverless manner, end-to-end. Also, as I was talking about microservices before, so that is also a very common use case of serverless. So you can create serverless backend and expose those as microservices to be consumed by mobile and IoT and web applications in the very similar manner by using API Gateway along with AWS Lambda. Data processing is another area where you might not think that serverless would be a good fit, but in reality, many of our customers are actually abandoning their existing ETL process, which are complex to manage and which are costly. With serverless, you can achieve real-time processing of your data and even equivalent to MapReduce jobs using Lambda's compute platform as well. Many of our customers use such capabilities to run complex ETL, image processing, video processing, and so on. Going forward, serverless computing is also very useful in building smart applications using chatbots and Amazon Alexa. You can use Lambda functions to enable voice capability and integrate that seamlessly with your front-end application. And last but not the least, autonomous IT is another area where we are seeing innovative use of serverless Lambda functions. Customers are using this today to create policy engine to extend the AWS services and manage the infrastructure. Now let's move on to discuss some of the customer examples and see how serverless computing have resolved many of the complex use cases for some of our large customers. So the first example we will look at is FINRA. So FINRA's audit order trail system, which is in short known as OATS, is part of an integrated system of audit trail for order, quote, and trade events for all national market system stocks and over-the-counter securities. This system is used to monitor the trading practices of member firms. FINRA uses the data from this system along with other market data to create the life cycle for each order, from receipt or origination through execution or cancellation, and monitor trading practices of member firms. Broker-dealers submit daily electronic data to this OATS system, which adds up to more than 50,000 files in each business day. As soon as these data files are received, the system needs to validate it to ensure that it is complete and correctly formatted by running more than 200 rules. In doing so, the system needs to perform over 500 trillion validations each day. Processing demand for these systems also varies significantly over time and can double or triple in response to market conditions that drive higher trading volumes at certain times of day or certain days of the week. Naturally, the requirement for such a system was real-time processing, infinite scalability, monitoring, performance, cost, and obviously low maintenance requirements. Now, why did they choose Lambda? They chose Lambda because their previous system was able to return validation results to broker-dealers within 3 to 7 minutes at peak times. However, with serverless Lambda, the processing time was brought down to less than 1 minute regardless of the volume. How was that possible? Because of the automated scaling built in the Lambda function. And not only that, it also shortened their dev cycle. So there were no complex distributed computing code to manage, and it was obviously more cost efficient. Using AWS Lambda, FINRA can now work more effectively with broker-dealers and more efficiently fulfill its mission of keeping the markets transparent and fair for all. The next example I want to share with you is of Fannie Mae. So at Fannie Mae, they run daily mortgage cash flow risk simulation process. Now, their existing on-premise HPC grids were no longer able to keep up with the growing business needs. It was taking more than half a year to add incremental compute capacity or integrate new application functionality. Naturally, it was very costly to maintain and refresh. They needed a near infinite scalability and unlimited storage. They were also looking to build a system which is easy to manage, cost efficient, and reduces the application development cycle. For Fannie Mae, Lambda was the right choice because with Lambda, they were able to scale up to 20,000 concurrent executions. In one particular simulation of 20 million mortgages, they were able to run it in 1.5 hours, which was more than 4 times faster than their existing HPC-based process. It also met their strict regulatory and security standards for the security and audit certification that I described earlier that we provide as part of our AWS security mechanism. And nevertheless, it shortened the new development time and was more cost efficient because there were no complex distributed computing code to manage. Another example from the financial industry is FICO. Their requirements was to build a system where the rate of request varies from 10K to over 300 million transactions a day. So with these wide variations, they were looking to have a system which can scale accordingly with the transaction volume during the time of the day. So Lambda enabled FICO decision management suite to perform computation on machine learning models much more quickly, cheaply, and efficiently than they were able to do before. They were able to decrease the processing time by more than 95% and significantly decrease the operational cost and operational overhead using AWS Lambda. With the Lambda architecture, it was also easy for them to decompose the functionality, and migrating to Lambda only took them a few weeks to migrate from their present system. Agero is also another very interesting example. They provide a wide range of vehicle telematics services to the automotive, insurance, and finance industries. They also created a MyLab application that used crash prediction models to speed up the emergency response and save lives. Agero needed a system that could continuously scale, seamlessly ramp up to the peak traffic, which can amount to more than 20,000 concurrent requests. With AWS Lambda, they were not only able to achieve these requirements, but their time to market was brought down dramatically to 8 weeks from concept to production for the new application. And with this event-driven architecture, they were also able to maximize the resource efficiency, seamlessly handle unplanned volume. They planned for 40,000 users but the actual user volume was 10 times that figure, and the system was able to scale seamlessly without any further configuration needed. Next, another example from news and media space. Thomson Reuters. They wanted to build a solution that would enable them to capture, analyze, and visualize analytics data generated by their offerings to provide insights to help product teams to continuously improve the user experience. They wanted to take ownership of the analytics data, protect information with encryption in transit and at rest, and handle thousands of events per second. The Lambda was the right choice because it works seamlessly with Kinesis-based ingestion layer with no servers to manage and no scaling needed for the ingestion layer. It can also be triggered by the events on the S3-based data lake. And there were no need to pay continuously for compute, and they needed to transform the data. Their initial test showed that they could process 4,000 events per second, and within a year, they were able to more than double that number to process 10,000 events per second, which amounted to 25 billion events per month. And finally, one more example from MLB Advanced Media. They built a real-time analytics systems to analyze the gameplay and player movements second by second and transform the sport by revealing nuanced details, generating the new level of excitement. With Lambda, the burst in computing capability during the game time was very easily handled. They could run code just in time in response to the game events and clean up the data and derive insight with millisecond-based latency due to the infinite scaling even during a very high-speed game. So as you see, customers in many different segments of the industry, starting from financial services to sports and news media, are using Lambda and serverless computing paradigm successfully this day to break free from the Iron Age to the age of freedom. And thank you for attending this webinar.